the variation. We have two types of variation. The first type is the direct variation, and the second type is the inverse variation. Let's have a look at this table. There are some values of x and opposite values of y. Let's have a look at x. 5, 6, 7. X is increases. X increases. X is increasing. As x increases, y increases. That's the direct variation. Let's have a look at this table. Look at x. As x increases, y decreases. That's the inverse variation. Y decreases. Let's analyze the direct variation. Let's have a look at x and y. You know, if we focused on x and y, you would find y always equals 3x. So y equals a constant multiplied by x always. And if you are going to take a value like this value, and this is x1 and this is x2, and take y1, the value opposite to x1, and take y2, the value opposite to x2. When dividing 15 divided by 18, simplify it, it will be 5 over 6. So x1 over x2 equals y1 over y2. And as I said, y equals, in this example, y equals 3x, y equals 3x. So we can say that y equals kx. What is k? K is a constant. Okay. Let's go to the inverse variation. Here we have x and y. As x increases, y decreases. And if you multiply each value for x by the opposite value of y, 1 times 24 is 24, 2 times 12 is 24, and 3 times 8 is 24. So xy equals k. Xy, x multiplied by y equals k. Okay? K is a constant. That is the inverse variation. And if you took x1, here 1, y1, the opposite value is 24. And if you took a value, any value like this value, x2 is 2, y2 is 12. We observe that x1 over x2 equals 12 over 24, because x1 over x2 equals what? 1 over 2. And y1 over y2, it's 24 over 12. If you divided y2 over y1, it's 12 over 24. Equals what? Half. So in the direct variation, if we have two variables like y and x, y, it changes directly as x. And y equals mx, or y equals kx. K is a constant. And x1 over x2 equals y1 over y2. And the inverse variation, you would find that y multiplied by x, or x multiplied by y equals k. And x1 over x2 equals y2 over y1. Look at this example. Y varies inversely as the square of x, not x, the square of x. You know what the square of x is? X to the power of 2. And here the variable is y. Y varies inversely at the square of x. Y is 1.5 as x equals 8. So that's y1 and that's x1. Okay. Find y. It's y2 when x2 equals 5. You know, in the inverse variation, we know that x1 over x2 equals y2 over y1. But it's not x, it's the square of x. So it's x1 to the power of 2. x1 to the power of 2 over x2 to the power of 2 equals y2 over y1. So x1 to the power of 2, it's 8 to the power of 2 over x2 to the power of 2, it's 5 to the power of 2 equals y2, I don't know what is y2, over y1. y1 is 1.5. So 8 to the power of 2 is 64 over 25 equals y2 over 1.5. Multiply here by 1.5 and here by 1.5. Okay. So y2 equals 1.5 times 64 over 25. Multiply it by using the calculator to do it quickly. 64 1.5 divided by 25 equals what?
3.84.
3.84. P varies directly as the square root of Q. So it's P and the square root of Q, the square root of Q. P equals 8, so it's P1. When Q equals 25, it's Q1. Find P, it's P2. When Q equals 100, it's Q2. Okay. So here, because it's direct variation, so P1 over P2 equals Q1. It's not Q1, it's the square root of Q1. As it mentioned, B varies directly as the square root of Q. The square root of Q1 over the square root of Q2. Okay, so P1, right, instead of P1, it's 8 over P2. What is P2? I don't know P2. I want to get P2 equals the square root of Q1. It's the square root of 25 over the square root of Q2, the square root of 100. Okay, so 8 over P2 equals 5 over 10. Okay, what is the value of P2? P2 in this case is going to be 8 times 10 over 5 by doing cross multiplying. It will be 16.